Hey there, this is Dr. Rishi from the Learners Academy, and I'm back today again with one more video on trigonometry. This video is related to the third identity of trigonometry, the identity that deals with cot and cosec. Before we go there, let us talk about what we have done in our previous videos. This is the seventh video in the series where we have made different videos dealing with the different parts of trigonometry. So far we talked about the basic trigonometric ratios, that is sine, cos, tan, cot, sec and cosec. Then we talked about the complementary angles of sine and cos and tan and cot and sec and cosec. Then we went ahead and talked about specific values of trigonometric ratios at specific angles, namely 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Then we went with the first trigonometric identity, that is sine square theta plus cos square theta is equal to 1. Then we went ahead with the second identity, which is 1 plus tan square theta is equal to sec square theta. Today we are going to talk about the last identity that deals with cosec and cot, and the identity says 1 plus cot square theta is equal to cosec square theta. Now let us start with our basics by drawing a triangle ABC which is right angled at angle B, and we would write the Pythagoras theorem for it. Before we go ahead, I will call this angle as theta. So obviously this would be my adjacent side and this would be my opposite side and this would be my hypotenuse. Now the Pythagoras theorem for this triangle can be written as AB square plus BC square is equal to AC square. So we would write the Pythagoras theorem for this triangle AB square plus BC square is equal to AC square, and then we divide. So we say dividing both sides by BC square, we get, so once we divide it, we'll get AB upon BC. So AB square upon BC square plus BC square upon BC square is equal to AC square upon BC square. Now this would further give me AB upon BC square plus 1 is equal to AC upon BC square. Now we already know that AB, that is the adjacent side, upon BC, that is the opposite side. So adjacent side upon opposite side is my cot, so I can write it as cot square theta plus 1, and my hypotenuse upon my opposite side is cosec, so I can write it as cosec square theta. So this is my third identity. This is not used as much as the sine cos and the tan sec identity. However, it has its own uses and is used majoritarily in proving sums in maths. It is not used as frequently as the sine cos and sec cosec sec tan identities used in physics specifically. It doesn't mean that it is not as important as the other two identities. However, the usage is slightly less in physics. But if you talk about it in the perspective of maths, yes, the usage is going to be exactly the same. Now, just like the previous videos and the previous identities, let us go ahead and manipulate this identity in such a way that we can see in what all forms we can see it, and it would be easier for us to utilize these forms when we are solving the examples. So we have cot square theta is equal to cot square theta plus 1 is equal to cosec square theta. I can also write it as cot square theta minus cosec square theta is equal to 1, or I can also write it as cot square theta cot theta minus cosec theta times cot theta plus cosec theta is equal to 1, or we can also write cot theta minus cosec theta is equal to 1 upon cot theta plus cosec theta, or we can also write cosec theta is equal to root of cot square theta plus 1. In the similar manner, we can write cot square theta is equal to cosec square theta minus 1, or cot theta is equal to root of cosec square theta minus 1. Okay, so these are the different forms that we can use. Obviously the forms are lesser as compared to the other two identities, because when we come to solving problems, there are going to be slightly less number of problems on this identity as well. Now, without losing any time, let us go ahead and solve some examples which are based on this particular identity. The first example that we are going to do is example number 2, sub question 2 from Selina Concise book for 10th ICSE. The example is as follows: 1 plus cot A square plus 1 minus cot A square is equal to 2 cosec square A. Now let us see how we can solve this particular example. So here we have 1 plus cot A the whole thing square plus 1 minus cot A the whole thing square is equal to 2 cosec square A. So we are going to start with our left hand side. The left hand side LHS is equal to 1 plus cot A square plus 1 minus cot A square. Now there are two entities here, 1 and cot A, so it can be expanded in the form of A plus B square, and this is A minus B square. So we have 1 ka square is 1 plus 2 times cot A plus cot square A, and we can go ahead with expanding the second part as plus 1 minus 2 cot A plus cot square A. Now in this particular expansion, 2 cot A and 2 cot A are having minus signs, so we can cancel them out and we are left with 1 plus 1, so it would be 2 plus cot square A plus cot square A, so it would be 2 cot square A. This would give me 2 as common, and I'll have 1 plus cot square A. Now, as our identity tells us, 1 plus cot square A is equal to cosec square A, so it would be 2 cosec square A, and that is equal to my right hand side, or the RHS. This is a pretty easy, simple, straightforward example. Let us go ahead with one more example from Selina Concise, which we would be taking slightly complicated as compared to this example. Now let us take this example from exercise 21A from Selina Concise book for standard 10th ICSE. The example is like this: cosec to the power of 4A minus cosec square A is equal to cot to the power of 4A plus cot square A. It's an interesting example. Now this example says cosec to the power of 4A minus cosec square A is equal to cot to the power of 4A plus cot square A. It's an interesting example because there are power of 4 involved in it. So now let us start with left hand side. Now there are multiple ways of solving this example. I prefer starting with the left hand side. So I start with left hand side. I get my left hand side is equal to cosec to the power of 4A minus cosec square A. So that can be written as cosec to the power of, I can have cosec square A as common and write cosec square A minus 1. Now cosec square A minus 1, if you look at the identity, can be written as cot². So I can write it as cosec² times cot². However, cosec² further can be written as cot² plus 1. And if I do the multiplication, I would get cot to the power of 4a plus cot to the power of 2a, or cot², which is equal to my right hand side. So this is how we would be solving these kind of examples. Every time you see a trigonometric ratio raised to power of 4 or power of 6, do not panic, because these are one of the easiest sums. All you need to do is find something common in them. Now let us take an example from practice set 6.1 for 10th State Board, that is 10th Maharashtra State Board. Example number 3. The example is like this. If cot theta is equal to 40 upon 9, find the values of cosec theta and sin theta. So here the example says cot theta is equal to 40 upon 9, and we are asked to find the values of cosec theta and sin theta. Now we can obviously do this sum by drawing a triangle and then finding the values. However, it is a slightly lengthy method. Using identities, we can do it in a way to smaller way. We can do it in a way to shorter manner. So let us go ahead and see how we can do it. I can write the identity. So I say by identity, cot² theta plus 1 is equal to cosec² theta. So therefore cosec theta is equal to root of 1 plus cot² theta, or that would be root of 1 plus 40 upon 9 square. So that would be root of 1 plus 1600 upon 81. So that is root of 1681 upon 81. So my final answer, my cosec theta, will be equal to the root of 1681 is 41 and the root of 81 is 9. So I can write this as 41 upon 9. Now we also know that sin theta is equal to 1 upon cosec theta. So that would be 1 upon 41 by 9. So that is 9 by 41. And that would be my final answer. Now that was all about the third trigonometric identity that is there, that is 1 plus cot² theta is equal to cosec² theta. This video is the last video where we talk about theories, where we talk about trigonometry in a theoretical manner. In the next video, we are going to deal with heights and distances. That is, we learn how to solve word problems which are related with heights and distances using trigonometry. Please like our videos, subscribe to our channel, and share these videos with all the students who need them. That was all for today. This is Dr. Rishi signing off from the Learners Academy. Thank you.